Okay, there's that.
Maybe you can stay all night. Shall I leave you my key? But you've got to give me a sign. Come on, girl, some kind of sign. Tell me, are you hot, mama?
Link.
You sure look that way to me. Are you old enough? Will you be ready when I call your bluff? Is my timing right? Did you save your
Okay, but we only have 5 students.
check it and see?
Supposed to have a lot more than that. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 5 out of 9. That's not good. Where's everybody?
I'm hot-blooded. I'm hot-blooded.
All right, well, I guess we'll just have to start with who we've got. Let's see, I see. Let's see, Jocelyn. I've got Christian and Marichelle. And who's here in person? That would be Litzy? Yes. That one. And Leo. All right, no sign of the others, though. Didn't miss an email from anybody, did I? No? All right. Guess that's all we've got. Okay. They'll just have to tune in later on with the YouTube video. So we've got a lot to cover today. It's going to be a real doozy. And we lucked out with our quote. I think it's rather appropriate, right? We're talking about the foundation of our geometry knowledge and the search for truth. That is the purpose of logic, is so that we can be certain that true facts and true conclusions are drawn. So let us go to, not that, that's algebra. Today's topic, valid reasoning. We've been using some deductive reasoning. Right? We used Sherlock Holmes as our main example yesterday. And so today is going to be a lot of vocabulary focused. All right? I'm going to take a lot of these ideas that we've been using in the past week and a lot yesterday, and we're going to give them all names. Okay? So please have out your notebook, either physically or digitally, and write these things down. You don't have to make Cornell-style notes for this, because I'm not having you read it on your own. But for your sake, to reference later, you're going to want these vocabulary terms in one nice, neat, orderly place. All right? And we'll go through the vocabulary. We'll go through 2 different types of deductive reasoning. And then at the very end, we'll get some practice in identifying and making use of that. All right? Angel, welcome to the party. All right, so we'll start with a logical argument. We've been actually making several logical arguments this whole time, but now we're going to be specific. When we say logical argument, what we're specifically referring to is a set of premises and a conclusion. Okay? So this can be any group of text or speech that fits that category. If it starts with premises and has a conclusion, it is a logical argument. I'm going to be using this as our example going forward. If it is raining, then the ground is wet. Statement 1. Statement 2, it is raining. Statement 3, the ground is wet. So that whole group there is my argument. That is a logical argument, composed of 3 statements. The first 2, the given statements, are the premises. Okay? Premise is a fancy term for things you already know or you're starting with. Okay? So we are starting with these. I am already accepting that those are true and they exist. I already know them, maybe based on some prior observation, maybe some prior knowledge, some previous inductive reasoning beforehand. However you get there, that's our starting point. Those are our premises. Right? I've then color-coded them and written a P afterwards to note these are my premises in the example. And the statement arrived at through reasoning is called the conclusion. So the one that you end with is the conclusion. And that would be my third statement in purple here. The ground is wet. I put a C after it to designate that's my conclusion. Okay, and Andre, thanks for joining the party. Please have out your notebook. We've got a lot of vocabulary for you to take down here. All right, so again, fancy terms for the structure we've already seen. The whole thing is the logical argument, composed of two types of statements. Either premises, the ones you start with, the given information are all premises, and the conclusion is the one that you will end with. So every logical argument will start with premises and work your way towards a conclusion. Now, this could be as short as 3 statements like we have here, or it could be longer. You could have a lot more premises, a much longer list that leads to one final conclusion, or you could actually link several of these together, right? These 2 premises lead to this conclusion, and then this conclusion becomes my premise for the next stage argument that goes in a chain. So I go from one level to the next, and then I have a new conclusion, and then from that I draw another conclusion, and you keep going down the line, and so you can create a much larger argument out of piecing together these base components. Okay. Now, how do we know if your logical argument is any good? Well, good is not specific enough. We have 2 different ways to tell if an argument is good in math class. We're going to call it valid and sound. Okay? An argument is valid if the conclusion has been arrived at through accepted forms of reasoning. Zoom in there again. If the conclusion has been arrived at through accepted forms of reasoning. That is, if you use the laws of logic properly, your argument is valid. If you don't use the laws of logic properly, your argument would be invalid. You did not follow the rules here. Notice nowhere in the definition did I say anything about being true or false. Take a look at our example again. If it is raining, then the ground is wet. That's a pretty general statement. I think we can all agree that is generally true, and that'll be true all the time. Statement 2, it is raining. Doesn't look like it right now. We got sunshine. So that premise right now is false. My conclusion, the ground is wet. Well, if you look outside, the ground is not wet right now. That conclusion is also false. Right? Because I had a false premise, I'm also going to end up with a false conclusion, but this argument is still valid. Okay? Even though I have a false premise and a false conclusion, the argument is still valid because it follows the proper structure. That's the important part. Validity only has to do with the structure. So comparing the two, a valid argument, right, is structure. Uses logic rules correctly. Okay. Sound, however, does have to do with whether something is true or false. Sorry, that's running off the page there. Okay. A sound argument deals with truth, but specifically the premises. For an argument to be sound, the premises must be true. And only the premises. Okay? The conclusion can still be false, but if the premises are all true, then it's sound. Which means a good argument, if we can use such a general term, would be one that is both valid and sound, because a valid argument, by nature of following the laws of logic correctly, that is also sound, if my premises are all true and I followed the rules of logic properly, my conclusion will also be true. So an argument must be valid and sound to guarantee its conclusion to be true. I'm trying to think of one that would be unsound here. Well, yeah, right from this argument, right, today, because it's not raining, premise 2 is false, therefore the whole argument is unsound, but it is still valid. Right? Notice I can't say whether the argument is true or false. The argument itself, the whole group of 3 statements, is valid or sound, or not, invalid or unsound. But the argument is not true or false. Individual statements are true or false. Okay. Any questions there on those distinctions? Okay, so going forward, of course, we're going to insist that we only deal with valid arguments. Okay? Sound arguments, well, that becomes a little trickier to pin down, because like this works as a simple, understandable example, but every day it depends whether it's going to be sound or not from a day-to-day basis, because the weather changes, right? But you need to be able to understand what is wrong with an argument, if anything. So that, you know, if you get into a debate with someone and you call them out on their BS because their argument is terrible, you're at least calling them out on the proper BS, right? Their argument can be perfectly valid. They followed the proper rules of logic, but maybe it's unsound because you disagree with one of the premises. It's like, yeah, that's great, and I agree with your conclusion if the premise was actually true. However, I have this fact here that says the thing you started with was actually bogus. And if you start with bogus, your conclusion is going to be nothing but bogus. That's what he's describing here in this paragraph. If you start with false things, an unsound argument, your conclusion can be anything. Doesn't do you any good. All right. Next set of terms. A conditional statement is any statement in the form of if something, then something else. So all that stuff that we did yesterday. We were examining Sherlock's dialogue to find and translate things into that if-then format. That is the conditional statement format. Right? If Watson had chalk between his fingers, then Watson was playing billiards. Right? It's a cause and an effect. So that is called a conditional statement. In contrast to a non-conditional statement, it would just be Watson was playing billiards. Outside of that if-then format, it's just a regular old statement. It can stand alone. Now, when you combine a conditional statement and a regular statement, you can create the first, most basic logic rule, and that is this guy down here, modus ponens. I'll say that without the mask for emphasis. Modus ponens. And there's one of my favorite phrases to say because it just sounds so funny, modus ponens. And that's a Latin term. This is where we get the name. And the structure of modus ponens is this. You start with a conditional, if P then Q. And then you restate the beginning part and conclude the latter part. That's it, that's all it is. It's this guy right here. This is an example of using modus ponens. So it's just the fancy word for the logic that we were doing yesterday. Right, I think they've got so here's the Sherlock Holmes example again, right? If P then Q. P standing in for Watson had chalk between his fingers. Q standing in for Watson playing billiards. Restate P. Okay, this is the most important part. Right here. Here is the basic structure. In most general form. Add this to your notes right there. That's modus ponens. Anything that fits that bill. Conditional. Right, we start with the conditional. Restate the first half of the conditional. And then conclude the second half of the conditional. Notice these match here, these match there. That's modus ponens.
What's the motherfucking word?
Nigga, I'm just not waking up right now.
Bruh.
Angel, I can hear you.
Do we have homework?
Okay. Any questions so far? No? Good? You need a drink? Need a drink? Okay. All right, next up. Very common practice we see all the time. We love to negate things, right? A 4-year-old's favorite word is no. Or maybe it's their least favorite because the parents are always telling them that. I don't know. But to negate something is to reverse it, to say the opposite, to say, no, that's not the case, not happening. Any form of putting not, you can contraction, don't, isn't, can't. Okay? All of that is negation. So whatever version of a word you want to pull from the English language that does the same thing. I don't care. We're mathematicians here. All of that falls under negation. So, for example, Paula will receive her inheritance. We could negate it by saying, Paula will not receive her inheritance. Just add that one word. Or you can be fancy, you can say, it is not the case that Paula will receive her inheritance. That way you don't have to add anything inside the phrase. You're just sticking that negation phrase in front of it. Undoes the whole thing. And if you shorten the statement to just a letter, we want to write the not in front of that letter. So do not reduce Paula will not receive her inheritance to just P. Keep the original statement, Paula will receive her inheritance, as one letter, and put the not out in front if you are negating it. All right? Trust me, this whole reduce the whole sentence to a single letter is going to come in way handy because You do not want to rewrite the same sentence 7 times in a row, okay? So it's some shorthand, but it's useful. But we don't want to go so short that we lose some of the important components. That negation is important enough. It needs to stand out. And of course, if you can negate something, you could negate the negation and pull a double negation. This as people trying to get around the rules. It's like, well, did he say you could do that? Well, he didn't not say I could do that. Right? It's a double negative. Double negative means the same as the positive, just like numbers. Multiply negative times a negative, you get a positive number. Same thing here. If you say, it is not the case that it is not raining, that means it's raining, right? It's not raining, it's raining. Double negation. Totally a thing you can do, and we make use of it all the time. Sometimes purposefully, sometimes accidentally. So in here we're going to make sure we use the double negative with purpose. Okay. Here's where the negation can come in handy. Our second logical rule is called modus tollens. And this is much like the opposite of modus ponens. It works in reverse, making use of that negation. So here's an example. If Watson wished to invest his money in South African securities with Thurston, then he would have had his checkbook with him when playing billiards with Thurston. Right? Translate that into modern speak. If Watson wanted to buy something, then he would have brought his wallet, right? You kind of need your wallet in order to buy things, agreed? Well, of course he would have. But we've observed Watson did not have his checkbook when playing billiards with Thurston. He didn't bring his wallet. If he didn't bring his wallet, he can't buy something, so clearly he didn't actually want to. That's the reasoning there. So here then is the format of modus tollens. It's very similar setup. You still have the conditional statement, if S then T. Different letters this time. But notice the second statement is not T. It uses the second half of the conditional, the part after then, and negates it. And our conclusion now is the first part of the conditional also negated. Be sure you don't miss that. To successfully use modus tollens, you must negate the conditional's conclusion and get a negation of its condition. Uses a negation both times and works backwards. You get this from the second half, you go to the first half. Let's go back to our raining and wet example. I did not get wet when I went outside. Fair enough, that actually happened today. I went outside, I didn't get wet. But I know in general, if it is raining, then I get wet when I go outside. Assuming I'm not carrying an umbrella or something. So therefore, it is not raining. And today, all of this is true, which means that's a sound argument. It's also a valid argument because this is the modus tollens format. I have, right here, a conditional, if R then W. I have a negation, of the second half of that conditional, not W. And my conclusion is the negation of the first half of it, not R. This is probably the trickiest one. It's the only one that deals with negations, but we could have negations in modus ponens. Excuse me. So do watch out for that. In real life examples, these statements could all have a negation already. It could be, if not P, then Q. Statement is not P. So long as these match, these will match. Okay? So long as these don't match, then these will not match. They will be the opposite. And that's where the double negative comes in. If you start with a negative, modus tollens will conclude the negation of the negative already. So you'll be back to positive statement. So watch out for that. Okay. Any questions on modus tollens? No? All right, then we've got one more thing to look at. The Venn diagrams. Or more accurately, because there's not the typical crossover. Usually when you imagine Venn diagrams, you think of the two circles like partially overlapping each other. These, because we don't have the partial overlap, they're technically Euler diagrams, just named after a different guy. It's no big deal. Venn diagram works. But this is especially useful if you're a visual person, because this is a visualization of this statement, if P, then Q. If I'm already dealing with, I know P to be true, then I have to be in the realm where Q is also true. So for example, if Spot is a dog, then he is also a mammal. Right? And that should ring true for you. That's a sound statement. It's like, yeah, that's true. I know all dogs are mammals. That's how the biological classifications work. All of the dogs are in this circle P. And that circle itself is inside the larger circle mammals. Okay, ellipse, whatever. So anything that can go inside the dog circle is also automatically inside the mammal circle, right? And then you can also see from this that just because you're a mammal, you're not automatically a dog, because I could be right there. I'm in the mammal circle, but not the dog circle. And you know that's true. Like, of course, yeah, there are other mammals that are not dogs. So this is a visual statement of this statement and only this statement, not the reverse of that statement. Here then is a negation. If P, then not Q. If Spot is a dog, then he is not a fish. Because if you're inside the dog circle, you can't also be inside the fish circle. They are two totally separate circles. There's a giant space in between them. No overlap, no circle inside another circle. So that's a visual representation of if P, then not Q. I personally also like to think of these in terms of maps. Right? Think about, if you live in Chicago, then you also live in the state of Illinois. All of Chicago is inside the state of Illinois. So this would be Chicago, and this whole thing would be Illinois. There can be other people living in Illinois that are not in Chicago. Right? I could also say, if you live in Chicago, you do not live in St. Louis. Those are two separate cities. You can't be in the same one at the same time. In two different ones at the same time, right? Okay, any questions on the Venn diagrams? All right, then you have the rest of the period to work on the exercises. We're going only with the odd exercises, odd numbers only today. Briefly, I'll show you each of the sections so you can see what types we're dealing with. The first set, you're going to use the legend here to translate from symbols into English. They give you the short version, if P then Q. You are going to rewrite this statement. You're going to write if. You're going to write then. But instead of the P and the Q, you're going to replace them with the phrase, I get a job, and Q will replace with the phrase, I will earn money. Okay? But make sure you still keep the ifs and the thens and the other extra nots and things. Let's just swap one for the other. And then the next set, same thing but backwards. Now they give you the whole thing, and you want to replace these statements with their associated letters. If today is Wednesday, becomes if today is Wednesday is P, if P. And you continue from there. Make sure you include the if. The P only replaces today is Wednesday. Any additional words outside of that phrase, you still need to write. Okay. 9 through 11, you're drawing a Venn diagram based on these conditional statements. Just use those letters. And then 12 through 14, the opposite. Here are the diagrams. Translate that into a conditional statement like here. Okay, you can refer back to these examples. These are the only two types of Venn diagrams you will be drawing and dealing with. Circle inside another circle, or two totally separate circles. That's it. Those are the only two types we have to deal with right now. Or blobs. I guess these aren't really circles or ellipses. Right? Shape inside another shape. All right, and then finally, we have 15 through 29. This is going to be the toughest one. This is where you have to think. In these ones, you are going to identify what, if any, logical argument is being made here. Is this an example of modus ponens or modus tollens? Or neither? If it's neither, you're going to say there is no valid conclusion. Neither, right? It is not a valid argument. But if it is one, tell me which kind, translate that into a complete symbolic argument form, which means you're going to have to take each statement, assign it a letter, and then write out the format of modus ponens or modus tollens with those letters, and then give me the whole conclusion. So for example, number 15 says, if Sherlock Holmes gathers all the clues, then he will be victorious. Sherlock Holmes gathers all the clues. I would ask myself this question first. Did I repeat myself when I read through that whole thing? You're shaking your head yes. Yeah, I totally said the same thing twice, didn't I? That's good, because if I never repeated myself, we'd have two completely mismatched things. Nothing's happening here. There'd be no valid conclusion. But I did repeat it. Which part was repeated? Sherlock Holmes gathers all the clues. Was that repeated from the first half of the conditional or the second half? That was the first half, right? And did I negate that statement or not? Is it exactly the same, or did I add a not to it? It's exactly the same. If I repeat exactly the same, the first half of the conditional, I'm in the realm of modus ponens. Right? If instead I repeated the second half, but I negated it, then it'd be modus tollens. Right? That's the other structure. Okay. So I identified modus ponens. Now I have to give them all letters. So I'm just going to highlight this piece and say, let's call this C for clues. And the part after the then, he will be victorious. We'll say that statement V for victorious. You can use whatever letters you like. I like using ones that show up on some of the important words. And now we'll set up a modus ponens argument using those letters. So statement 1 was, if C, then V. Statement 2 said C. That's it. It was that simple. Statement 3, I've got to come up with that myself. That wasn't already written. Would be to say V. That's how by modus ponens, I can just write, actually, let's do one bit. Let's say therefore V. So we know it's the conclusion. And then finally, for these exercises, go ahead and write out that conclusion in English. So give us the full version. Therefore, he will be victorious. Okay? So that's the kind of thing you'll be doing on 15 through 29. And there's a couple more interesting questions after that. Again, you're only doing the odds. So there's total, so you'll stop at 33. So you've got, 17 questions? Okay? We've got 5 minutes to work here. Go ahead and get started. You'll be able to at least finish that first section there on the translating. And if you do get stuck on anything, please feel free to ask me, send me an email. My plan is I thought we would go on to the next section tomorrow, but if there's a lot of questions, we can spend some more time on this